So, introducing myself, my name is Lorenzo Mangani. I'm the CEO of QXIP and the co-founder of the Homer project. And today we're going to talk a little bit about Homer 7, which is our new release. So that's going to be a little bit of everything. The presentation is quite live, so I'm going to be talking perhaps a little bit over different or diverging from the slides, depending what I see in terms of reaction. So good morning, and welcome to Homer 7. So again, name is Lorenzo Mangani. Our company is QXIP. The project is called SIP Capture. Those are the main URLs where you can find my hex experiments and the official releases. You can see our Twitter ID if you want to mess with us or ask us questions, and my LinkedIn in case you want to see what's behind the curtains. As mentioned, our company is called QXIP. We're based in Amsterdam, in the Netherlands. We're a small R&D, so we don't have ambitions of commercial nature much, although we do have some commercial extensions to our stack. We're lucky because we have a whole lot of users and customers worldwide, so our project seems to solve a problem. So we have a whole lot of inbound and a whole lot of opportunities to make it better by interacting with real case scenarios. So there's not much theory really in our product. It's all designed to meet the needs of those that use it. Homer is not our only project. There's a bunch more. If you go on our GitHub, you will see them. They span quite far away from VoIP necessarily, so there's a bunch of database elements, deep packet inspection libraries, peer-to-peer synchronization protocols, and a whole lot of other things that we use as part of our development. Besides the company, I hope I got the icon decent, see if you recognize yourself in either. Outside of the company and the employees, our project is really supported by contributors, so we couldn't exist without the open source community that uses and powers back SIP Capture and Homer. Today, first row, we have Eugen, who's the man of the year, and you'll see why later in the presentation. But sometimes the major directions can come also from the outside. So it's a lesson learned also for us. Always listen to what the contributors and the people using the projects care about. If in between the audience there's anybody else that has interacted with us or ever submitted an issue or a comment or anything, thank you. That's exactly what we need. If you haven't already, please do. We're easy guys, easy people, are not too hard to talk to. So the agenda of today, which I think I did not update, but just a reference, a little bit of background. Now we're going to talk about Homer 7, what it's about, its specialties and what has changed, how to get it, and then a little bit about our project. So for those of you who are unfamiliar, and we'll see later, a little bit of history. So Homer is not Homer Simpson. It's the Greek poet Homer. So that's the inspiration behind it. And I'm lucky enough to have studied Greek, so we're going to spend 15, 20 minutes explaining you this part, which tells you, I'm just kidding. So Homer is a VoIP and RTC monitoring tool. This is what we like to frame it as, but it's really not. It's just a bunch of modular elements that work together to achieve this goal. So not really a product, but rather a set of modular elements that we chain together. Active and passive troubleshooting, mostly passive, but we stepped into active during the last year, and we continue going in that direction so that people can get the best of both worlds. Signaling and network protocols, so not only SIP, but the stack now is able to receive other types of protocols. So this is why I mentioned deep packet inspection, some other libraries that we're working on. And thanks to Eugen a lot, now also about time series and serious quality statistics. The real raw power behind Homer and why it's allowed to be popular is really the HEP encapsulation protocol. Does anybody know what it means, what it stands for? You win a t-shirt. So, correct, the Homer encapsulation protocol is natively supported in all of the projects that we love and use every day. This makes it easy to plug in Homer without coming up with the difficult part. So you just flip a switch and you start getting data. This is why it works. The protocol is open, which means that anybody could do the same thing or integrate the same features in other platforms. We kept it open because it's the most important part. Why do we do it? Do we really need to capture packets? Do we really need to do it this way? A bunch of people, have different answers. So, many things that many, believe that they can do this later. Many things that they're okay with logs. I have a bunch of logs. I'm all right. I don't need to capture any packet. Or they're too busy to think about this. They'll do it when they have a problem. Or they think they can travel back in time and get a pickup somehow from the past without thinking about how to implement it. This is, of course, BS, so it doesn't really work that way. We see companies and engineers committing those crimes on a weekly basis. So whether you're an operator carrier, you run a calling center, you're an enterprise with your own telephony system, you're a vendor, or maybe you're a developer, you're working on a platform, it is absolutely critical to think about this early on. So a few lessons that we learned. And I'm just generalizing here just to see the feedback as well. Why it's important to do it early. First of all, from developer standpoint, if you do this early, you're going to find things that you have no clue are happening on your network. And this is, applies to everyone. I see some of the best developers that I know discover something about, their implementation only when they look at the passive version of it. So, in theory, it's always perfect. You did a great job, or you implemented a library that you trust 100%, it's going to be fine. But it's really not many times. So looking under the hood is absolutely important. Whether you design your own service or you just buy it from somebody else, think about how you can capture it, how you can monitor it independently. Don't rely 100% on somebody else to eventually come up with this. It doesn't work that way, especially when you have a problem. Another point is that complexity is really the hardest thing to capture. I mean, packets are easy, but complexity is not. So the sooner one starts to design their, let's say, capture environment, the better. Because over time, it gets really expensive. We're lucky enough to serve some very large operators and enterprises, and even they make this mistake. And when you commit this mistake at a large scale, sometimes it costs a whole lot of money just to, get it together quick enough. And, some of our vendors will ask millions of dollars to get something done at a scale of a large international carrier. So Homer allows you, to think about this step early on, make it part of your ecosystem, improve it over time, but at least you'll have something. And the other aspect is that this promotes technical knowledge. This is how I became a SIP engineer. I come from a completely different background. I'm actually an audio engineer. So I was doing sound design and completely other things. And then I was lucky enough, about 12 years ago to step in an environment where, monitoring was the thing. And everything I know about the SIP protocol, I learned it looking at passive captures myself. So it's something that I have very heavily endorsed in terms of, promoting tier 1 into tier 2s and 3s. The higher you fly, the harder you drop, right? So same thing here. Besides the simple troubleshooting, monitoring a lot of times is about, finding about actual customer issues or issues that have a revenue impact. So, if your calls are not completing, you're immediately losing money. And then quickly after, you're losing customers too. So it's a very thin line between love and hate. We see in our experience that the best accounts are going to be the ones, breaking your heart when things go wrong technically and you can't help them. As opposed to, being able to provide honest and transparent troubleshooting, which is what we're all about. So, in our experience, when one of our customers is dealing with troubleshooting with their customers, the transparency factor is absolutely important. You need to establish trust. You need to show them what's happening. If you can get them access to that trace very easily, very quickly, they're going to trust your analysis of the problem, and probably they're going to take the blame because 99% of the times this is happening on their network. It's their router dropping packets or injecting jitter. You just have to show them, in order to be believed. So hope for the best and prepare for the worst, I guess. It's the main lesson here. So if you make Homer or anything else, really, any other solution that actually allows you to capture packets and look at what's happening on the network early on, you're going to basically have an insurance on both an engineering and operational level. So how many of you actually already solved this problem? Right? Not enough, so perfect room to be in. It's something really to think about. And hopefully, we have a solution for it. And before we jump into the how, you already, I guess, know what Homer is about and how it captures, but there's an old Homer and a new Homer. So if you go on our repository right now, you might get confused. There's a 5 and there's a 7. 5 is the former version, or the X, or it's still stable. It's perfectly stable, but it has a few known limitations. Namely, it's SIP-centric. So this was designed with SIP in mind. So everything goes around SIP. You can inject logs, you can have statistics and a bunch of other things, but they're SIP-centric. So unless there's a SIP session captured to link all of those pieces together, they don't. So in Homer 5, you can capture logs, but you cannot search for logs. They only show up if you open a SIP session that's related to them. Same thing goes for statistics and everything else. There was no ability to implement custom protocols, mostly because Homer 5 existed within OpenSIPs and Kamailio. So it's using the SIP capture module to basically recycle all of the skills in OpenSIPs and Kamailio to do the parsing and everything else. But this also means that we only can do what those platforms can do. And custom protocols are, of course, not a thing much. Or, well, we could do it, but you can imagine how quickly it would become obsolete if it's not part of the native stack. Search was limited, statistics super limited. It was running on a very outdated and old-fashioned PHP plugin that was really ugly to extend. So even people submitting patches and bug reports were always having a hard time even doing the simplest things. The deployment was complex. So a lot of moving parts, a lot of configurations, a lot of changes depending on the version of the backend. So if you were using OpenSIPs or Kamailio 4, 5, a whole lot of small, tiny differences that were confusing the hell out of everyone. And no UI integration. So Homer 5 is an island. So you will find everything that Homer knows in its UI, but it's going to be really uneasy to be connected with something else. How do we fix it? So the first thing that we did, and this happened, again, largely thanks to Eugen, which we can't praise enough, we have standalone capture service. So again, back to the beauty of app. App is an open protocol, which means that anybody can pick it up and implement something with it. Eugen did exactly this. So he took the app protocol and the baseline logic and he implemented a standalone capture server. So in Go. And later I did the same in Node.js. We implemented 2 completely self-standing solutions to capture those packets, or actually receive app traffic, store it to database, and provide the foundations for the new Homer. So we're finally protocol agnostic. So this new system is not SIP-centric anymore. So any protocol is as good as any other protocol. They're dynamic, they're configurable, which means that anybody can go in tomorrow and say, okay, let me implement DNS search. We already have DNS capture in Haplify, which is one of our new agents. If somebody wanted to make it searchable in the new Homer 7 UI, it'd be probably a matter of a couple hours of hacking around and copy-pasting and changing some variable names. Everything is indexed as JSON objects inside, so we're using the new features of Postgres 10 and 11. They also exist in MySQL, but for whatever reason, we decided that the Postgres implementation was more mature for the purpose. And it provides full search for anything that we have inside. So this includes also wildcard searches against the full SIP message, which in the previous version was only possible from the database. So you could go and look for, I don't know, the from user and the to user, but not like do a wildcard CSEC 20 against all of the packets in a range. Now it's possible. So this is a huge, huge, huge improvement. We also have cascading correlation, which is a really necessary concept when you make something multi-protocol. So let's make an example. We're capturing, well, the simplest case is we're capturing SIP protocol logs from a bunch of systems and RTCP statistics from a bunch of devices. Those are going to be connected between them in, well, no, not really mysterious, but sometimes complex ways. And in Homer 7, we have the ability to define those correlations without touching the code. So it's just config files where we can say this protocol is related to another protocol. This is how you connect two fields. So it's kind of a relations, let's say, between those protocols. So we can say, I don't know, the SIP call ID of one protocol maybe is equivalent to the session ID of the log. So we can connect those so that every time we select either, they find each other. And it's really clean and easy. The time series, I guess, are the most powerful part. So in the previous Homer, as said, we were storing everything in the same database. Cool, but not powerful. So it was really hard to get the statistics aside the packets that generated them and do something with them. The new capture servers do allow to emit actual time series. So they connect to Prometheus, to Elasticsearch, to InfluxDB, and you can do a whole bunch of cool things with it. The backend is now Node.js based. So way more accessible, way more developers that have familiarity with JavaScript, and they can fix something without looking at the backend or front end as two separate parts. They're very tightly integrated and easy to hopefully develop. We'll see this how it goes this year. So a self-sufficient ecosystem and a headless mode of operation. So right now, it's possible to do something to create a headless Homer that does something without a UI. So maybe you only care about taking statistics as of what it's happening, send them to your favorite backend, and that's it. You don't want to capture any packets. You don't care about anything else. You don't want to search. You just want to know what's going on from a passive standpoint and do something with it. So this is the new flow of Homer 7. I decided not to go into the 5. Who cares? This is the future. So from left to right, we have capture agents, capture servers, and backends. So first column, most important, you see a new name at the beginning, Haplify. There's a Haplify and a Haplify server. Those are the components that I mentioned Eugen is working on and is leading the development of. It's a simplified version of the agent. So once again, complexity was the problem. Kept agent, that it's our own implementation of an RTP agent, are beautiful but complex, and it turns out that 80% of users, they don't care about the advanced stuff that we did. They're happy with the default. They just push it. It works. That's fine. Great. So that's what Amplify does really well. So it's something that you can just download, chmod plus X, and run. You don't have to do anything anymore. You don't have to bring libraries into the system much, and so on. You still can use, of course, the other agents. You can still use OpenSIPs, Kamailo, Asterisk, FreeSwitch, whatever else, RTP engine, and now also RTP proxy. I'm not sure if everybody's aware of it, but RTP proxy grew a pair of HEP features. So it's now able to send statistics and correlation using the HEP protocol. So before we had to do it through logs, and it was a whole lot of complex scenario. And then, of course, we have simpler tools like sngrep and segrep, which you might want to run, one-off, just to grab something from a remote system. Let's say, you're on somebody else's system, you just want to capture a call, send it to your Homer, so that you can troubleshoot it later. One-off scenarios. In the center, Amplify server, as we said. So this is the part that replaces what was inside the SIP capture module in Kamailo and OpenSIPs, and it makes it an alternative method of doing the job directly. Or HEPOP, which is basically the same, but in Node.js. And this is more of an experimental branch, but we want to make the point that multiple capture servers can exist. We don't need one to do everything or to be good at everything. We can have many. They can work with the same backend. They can be attached to the same UIs, and they can do different jobs. In this case, Amplify server is really, really good at the SIP, RTCP part and correlating them. HEPOP is better at the RTC protocols right now, so it supports the same for SIP and so on, but it also supports Janus events and MediaSoup events, and the correlation between them. So it links, this is the audience. So it links those two realms together. So you might have scenarios where you're happy with that, or maybe you need to plug in something custom. With HepPop, it's a matter of minutes spinning up something and sending some traffic. Sorry. Last part, as we said, Postgres 10 or MySQL as well. It's implemented even if it's not really in use in the default recipes, but I think it is fully supported. And on the bottom part, the best of everything. So Prometheus, InfluxDB, Elasticsearch, MongoDB, and RethinkDB are currently supported between the two. So you can take all of the packets or just the statistics or both and mix them between the two. Something you want to store it in a relational database for search, something else you just want to send it to your analytics, or maybe you just want to send everything to Elasticsearch, right, and do all your magic there. So let's see how it works. And I apologize if this looks a little bit intricate, but left to right, so we see a HEP source. So this could be a Camarillo, Asterisk, or whatever you have that's HEP capable, or it could be your own capt agent or Amplify. They're going to be capturing packets wherever they're deployed. They're going to encapsulate them using the HEP protocol and send them down to the capture server. In this case, as we said, it could be Amplify server or it could be HepPop, depending on the purpose. As they make it into the server, and this is a generalization, they're going to be switched depending on the HEP type. So as we said, now we have many HEP types. We have SIP, but we have statistics, logs, RTTP, the Janus protocol, the one that one of you will define in the next months to solve their own problems. So they get sorted. If necessary, we create tables for them. So let's say a protocol one can have many transaction types. So let's say for SIP, which is protocol one, we have calls and registration. So we want to store different types of traffic within the same protocol in different boxes so that we can quickly go through them and sort them without making the complexity high. They're going to be queued, and the big feature that we have now, which makes a huge difference, that we do bulk inserting. So in the previous implementations, they were basically flat inserts, so the performance was suffering a little bit, and we were not leveraging to the max the bulk features of many of the databases that we support. So now we do, and it makes a whole lot of difference. So this creates an entirely different scenario, and by the way, each HEP type is bulked on its own. So there's going to be a bulk flow for SIP, a bulk flow for whatever else. They don't get mixed. And on the bottom part, you see that there's a switch. So as we switch by HEP type, some data goes into Postgres and MySQL, and other data takes the route of time series. So we're going to be interested at any point in time in knowing how many invites we have seen in the last 10 minutes and what the reply to those invites was, right? This is just generic information. It's very cheap. It's very small. We can keep it for years and months. So we switch it out of the heavily rotated packet capture database so that we can keep them for longer. And as you can see, there's a few implementations already up. So directly with Prometheus, which is the native emission of those time series, right? So there's a slash metric, basically endpoint in Amplify server, which at any point in time emits what the server is doing to a Prometheus endpoint. In this case, it can be either, as said, the actual Prometheus or Telegraph, which is able to translate it into other languages. This is what we use so far. So we can literally translate it to InfluxDB, which attaches to the Homer API. So this is going to be creating a circle, a loop that closes. Or we can send it to Elasticsearch, where we can do a standalone version of Homer without the Homer UI at all. We can just choose to send all of our statistics, all of our messages there, and be happy with it. Zooming in, this is a more detailed example. So Amplify is going to send some HEP, come into a HEP socket, where it's going to be switched. In this case, there's an example of multiple protocol types. So we have type 1, which is SIP. We have type 100, which is logs. And we have type 5, which is RTCP. Those get sorted and treated. They get logged to the database. And then they get correlated. And this is, I think, the interesting part. I hope it's not out of place, but I really care about explaining the beauty of this, because we're going to use it a lot as we go on. So a quick example, let's say that I make a search. So I'm searching for SIP. I'm going to use a new feature. So I'm going to just look for a wildcard invite. So just everything that has the word invite in it, I'm going to find it within the profile call. So only looking at the messages that Homer thinks belong to actual calls, not registrations, not keep alives. Homer is going to find some results. And as it finds results, it's going to apply some rules that we have configured in the backend. In this case, we have two examples. So we decided in the backend to correlate SIP with type 5. So we're going to look for RTCP statistics related to the calls that we found and to the log types. So we're going to look for logs that are relevant to the calls that we're investigating. How do we do it? Is basically by creating this correlation that I was talking about. So the source field is going to be from the original protocol. So we're going to take the call ID of the SIP session in this case. We're going to do a lookup for type 5 using profile default. This is the default for any new protocol, unless it's more complex. Only SIP right now has multiple types. Everything else is just default. And we're going to look up the SID field in this new type. So we go from call ID to SID. And we're going to also extend the range. So sometimes when we correlate a protocol, so let's say that we're correlating SIP to logs. Typically, the logs about the SIP session that I'm going to investigate happened a few seconds before the invite. Maybe that system said, OK, I'm opening a new leg, and I'm about to send an invite to an endpoint. This is before. So the lookup range allows us to extend the range of a search. So let's say I'm looking at 10 o'clock. This is going to go minus 300 seconds and plus 200 seconds. So it's going to look back and forth for anything that's relevant. So it's very easy to customize it depending on what the data source is. And what happens at the bottom, so every time we find a correlation, it's basically pushed into the stack. And what we get is something like the timeline at the bottom. So we're going to have a few invites, then we're going to have a log, some more invites, a bunch of statistics. This is probably between 200 OK and a buy, some more messages closing the session, and then a log, which is probably, I don't know, a CDR. So this is the typical outcome of the correlation. Do you guys have any questions? Does it make any sense? OK. So what happens when you trigger this mechanism is the following. So this is a little preview of the call flow in Homer 7. So you can see on the left, we have two IPs just exchanging SIP. And then all of a sudden, the system, the same system that's handling the SIP part, so our server, also generates a log that goes somewhere. And if we open those two, you see they appear together. So they're just correlated automatically by Homer without giving it any input. It was just going to say, hey, this logs belongs to this session. And it's just going to display it as part of the flow. So you no longer have to go into another tab or something. Everything that happens in a session is now part of the call flow. So you can see exactly what happened where during the duration of a session. So how do we look at it? So this was just a preview. So to the phallic nature of our logo, I picked this example. Homer 7. Homer 7 is the new UI to the stack. So as we said, all of the backend elements are standalone. They can be deployed on their own. You don't really need a UI unless you're going for it, right? So you can still use Amplify Server to create something headless. If you don't want a headless version and you want to search, which is, of course, one of the main features, so it's useful for many, there's the Homer app. So Homer app is replacing the previous Homer UI and Homer API at once. 1 second. It's going to replace those two elements with a single one. It's developed in Node.js for the backend part and Angular for the front end. It tries to recreate, of course, the experience of the previous Homer, so it's not like a total remix. It's still time range based, so flexible UI, you select the range you want to work on, you have customizable elements, and it's kind of the same workflow. So if you're coming from the previous version, it shouldn't be like a heavy shock. But it does have a few differences. The dashboards are now dynamic, so each user can finally make whatever they want, so they can create their own search forms. They can create their own statistics. This is an example of the InfluxDB integration. So Homer app can basically attach to InfluxDB right now. We'll add also Prometheus and other backend support. This is the first one that we had time to do. And basically reads all of those time series that we were writing from Amplify. So it's actually connecting to multiple databases, one for search and others for fetching the statistics within the same range. So if you open the settings of one of those widgets that you can find in Homer 7, it's basically going to look like a chronograph in terms of selecting. So you have the measurement name, you select one or more counter names, and then you can group them by tags or isolate certain values. So it's pretty much 1-1 with the way it's done. More interesting is the search farm. So the search farm is still an evolution of the old one. And this time it allows everyone to do whatever they want. So before we had this customizable farm, but it was the same for all users on a Homer deployment. Now each user can make their own. So by editing the widgets in their own dashboards, they can basically decide what they want to look at. In this case, the default, as you can see, is called SIP search. So we're searching for SIP calls within a specific profile. In this case, as you can see, there is a default selected and a bunch of fields. If I change SIP to something else, those fields will change as well. So if I switch from SIP to log, all of a sudden I'm going to have a completely different set of search fields that I can select. So this is how you can, in the same dashboard, make different types of widgets for different types of protocols, keeping in mind that they correlate between them. We have implemented SIP, log, the RTP statistic search, and the Janus protocol for now, and we'll keep adding more as we go. When you make a search, this is how it looks, more or less. So there's a dynamic grid, still an evolution of the old one. This time it's a little easier to customize it, and it has a little more filtering options. So you can do grouping, you can do a bunch of other things that are right now pretty common sense. Still, as per the old one, you can either select a single element or you can select a session ID. As you can see, there is no more call ID, so we kind of unified the whatever is the unique identifier of a session in Homer 7 is called session ID, SID. I'm not sure if this is going to stay the case, but in the example, that's what it is. When I open SID, as you can see, I find a bunch of correspondences. In this case, it's I think we're looking at an OpenSIPs example here. So we have we're seeing invites and replies, and X logs from OpenSIPs, which is able to generate custom HEP payloads to the platform. It's correlated automatically. The call flow, we have seen it. So if this session has logs or if it has statistics, whatever it is related to is going to show at once. So it's all in one. You don't have to go and look for something. If Homer finds it, it shows it to you right away. And hopefully this makes it easier to understand, the timeline of what we're looking at. It's no longer network only. So as we said, we're doing active and passive, but we also can do internal application tracking right now. Janus is the perfect example for this. So there are elements that are actually going out onto the network, and there are elements that are only within a platform. So they're never actually transmitted. In this case, we can finally capture those events and make sense of them together with network ones. So if you have a platform that's generating some packets, but it's also generating some lookups, let's say internally, now we can finally display them and give them sort of a sense in a timeline or in a flow. So where did the stats go? Let's take a deeper look at what this produces in real life. So on the left, you can see the chain. I just picked a couple of simple examples. Things can get way more complex if you wish. And in this case, let's imagine we have an Asterisk where we enable SIP and RTCP monitoring. So this platform is just going to bomb everything in HEP to one of our collectors, in this case, Amplify. And within Amplify, we're going to do the trick that I showed you before. So Telegraph is going to farm statistics into InfluxDB. And Homer app is going to attach to InfluxDB as well as Chronograph. So you can have a choice of using our own interface or using the native one of the stack that you decided to use, which is many times more powerful and more fun to do it. Simple example here. So as you can see, Amplify, which is the prefix. So we kept this so that you know what's generating what. Amplify generates a whole bunch of very useful and precious statistics from all of the type of sources that it supports. In this case, RTCP jitter. So it's looking at RTCP. It's looking at what's inside those packets, and instead of just writing them down, it's going to make statistics. So I know that I had an event about RTCP somewhere on my network at a certain point. Of course, what we want to do with those events is create alerts. And this is a really dummy example, but I think it incarnates what we're trying to do or what we're trying to make easy. So what you can do right now in either InfluxDB or other platforms, or with Prometheus with the alert manager or so on, or in Elasticsearch with Sentinel, which is one of our alerting plugins, is just attach to a specific metric on your network and just watch it. So in this case, we have a watcher for a jitter, and we want an alert every time it's greater than 50, just a random number for the example. The recipe is going to show you already what's coming. So if we have a match, in this case, it's going to show that our alert is actually going to trigger at a few minutes to 19. And you can choose what you want to do with this using the power of tools that people much better than us developed already. So again, it's capacitor for the InfluxDB stack, together with chronograph. It's alert manager in Prometheus. It's Sentinel in Elasticsearch. Use the best thing and the one that you love the most. We'll produce the data, we'll make it compatible with it, we'll send it there, and then you can have your fun. This is another example from Eugen's setup, which is, I think, the most powerful and complete. And this is a screenshot from Grafana, right? So you can take a look at this. I mean, it's pretty self-explanatory. We're looking at call setup time, receive jitter, receive packet loss for an entire network. And in this network, we can have one or many Amplify servers. Those Amplify servers might be tagging the traffic depending on its source and destination. So they create, a zoomable set of time series where we not only can find the anomaly, but when we do find the anomaly, we can find its correlation with what's behind it. Same thing we can do in Elasticsearch. This is something that I didn't manage to complete in the presentation, but it's complete in the repository. So you can have Asterisk send data to Amplify server, and Amplify server send everything to Elasticsearch. Everything, I mean packets and statistics. So this is a version or an implementation that doesn't have a Homer UI. It's just everything in there. If you're, if you're already using Elasticsearch to a large extent, you have a really good cluster, or you have knowledge of that platform, then why not use it? So we now allow this kind of integration where we just send it all there, and you can do your magic the way you want it. We also developed a few additional plugins so that you can do call flow generations. Those are free on our GitHub. So if you choose to go this route, we also give you a bonus of a few Kibana plugins that can basically fill the gap with what our UI is doing, and probably do even more. Last but not least, we're finally pluggable into machine learning. And again, the first example that we managed to put together is still using InfluxDB, and this is mostly because I'm familiar with that enough to do it fast, but it's not limited to this. I'm not sure if you guys are familiar with LoudML. It's a new player in the machine learning arena, and they have a new platform, which is free up to a certain number of models. And it offers basically a ready-to-go integration to do prediction and machine learning against data that Homer is producing. So Homer is going to create time series. Those time series can be now used within 5 minutes to train a model that's going to do predictions. So we're going to just say, hey, this is a normal week of my traffic. Now apply this model to the real time. So every time what's happening on our network is diverging from the model that we have created, we can have alerts without even programming them specifically. So we can just say, just every time it's different from the reality that I want, let me know. And it could trigger a packet loss, or maybe it could trigger a system that's no longer responding, or maybe a customer that all of a sudden is sending 3 times the traffic that you would expect. So very powerful directions. And again, they're all depending on the ability of Homer to be integrated. So hopefully that's what we achieved with this new version. So how do we install it? The best way to bite the apple right now is to use Docker. So we have a bunch of Compose and Helm recipes on our repositories that you can use to spin up everything that I just mentioned. I also added here the Homer 5 versions with Amplify, which is kind of a legacy setup. So if you want to just sit in the middle, keep using Homer 5 for whatever reason, but add the time series support, you can with the bottom 3. Otherwise, the top 3 are basically the examples that I showed you. They're fully functional. They come with presets. So this is just something that you go in, you run, you send HAP traffic, and it just works. And it already comes with a bunch of those dashboards that we have mentioned. So it's really the easiest way to do it. Otherwise, you can just take a look at what they spin up and do it on a real system. So for most of those cases, just go into the directory that you like most, Docker Compose up, -d, and off you go. HAP traffic by default is still on port 9060, so as per the previous version, so you should be able to just change absolutely nothing other than the IP on the sender. Now, just a little mention, again, I want to go back to what's really important. So all of this cool stuff happens because people use Homer and because people contribute to Homer. So we don't really have a whole lot of success on that point. So we literally have thousands and thousands of deployments, but we have dozens of contacts in terms of active reports. So if you decide to go the Homer route, please walk into the arena as an active member. So, don't just pull it, and if it doesn't work, ban it, or maybe raise issues without, expecting it to be a two-way street. We're loving this part of it, so we really depend on what people think or what their experience is, and sometimes things don't work, but what's important is to understand what you're trying to achieve and really not just the procedure. This applies to everything. So Eugen has been a contributor. So he literally took hours and hours, days and days to contribute code. That's not what we're asking, of course, out of everyone. Some people are able to do that, but for the most part, what's really important are the reports. So interacting with us, letting us know what the problems are, what the limitations are, what's preventing you from taking advantage of this is the most critical part of the circuit. Because if we're aware of that, then we can fix it. And if we're not, a lot of people that I tend to meet at these conferences come up to me and say, yes, we tried it, but, and there's a little something that's probably a well-known issue or something that can be solved in 2 minutes, but we just never knew. So again, be active. That's the part that we love the most. And that's also how to keep Homer alive. Little snapshots of the full stack. So this is the big picture now. So the two new capture servers, the RTC events. On the left, we have our classic agents. And on the right, we have all of the ready integration. So that's source code. Those are libraries. Those are pieces of code that you can use to just implement HEP in your next project. Be it, I don't know, a mobile application, a new whatever it's going to be, in whichever language, most likely. Those are not even all. It's just a portion of them. But most likely, you'll find a piece of code that you need already there, and you can just plug it straight into Homer and use it. And if you find something that's not yet supported, open an issue, because more likely than not, that's all we're waiting for. We just need somebody to have a use for it, and we can implement new things. And that's more or less it. And I don't know if we have time for a little QA, probably just a couple of minutes. But thank you very much for listening. I think we have probably, is it until 45? We have 3 minutes for questions. Go. I think there's a microphone up here if you want to walk up. Otherwise, just yell it.
I'm a consulting company, so I'm going around a lot of businesses. We got a lot of clients, and as far as we see, we heard like SIP is going to be the future, and the future hasn't arrived. Like there are a lot of companies out there using H323.
Okay.
Still.
Yeah.
And I was just wondering, can Homer, do you have anything to monitor H323?
We have the framework for somebody to do it right now in the Homer 7. We didn't do it. To be honest, we're looking forward right now. So it's going to happen that somebody implements, a legacy something. And again, the framework is there for supporting it. We didn't do it. I personally don't have enough requests for it. But it's possible, yes.
When you were talking about the logs, were you talking about, say, that I could interact with the Asterisk log, so if I put it into the logs, the call ID, it'll bring up all the logs that Asterisk generated, or?
Yes, well, it works for anything. So we have a little tool that's called Pastash. I didn't include it in the presentation, but it's on our repository, which is basically like a log stash for our stack. You can attach it to any log source that you want. You can use different types of matching. So you can use a regex filter or other methods to extract what you think is the correlation ID, and then send it as HEP. So this applies to everything, and it's also the way we do correlation right now with the old RTP proxy, for instance. So we look at the debug logs. From there, we take the correlation between the legs that you requested and the one that is signed, and so on. So it's very flexible, and yes.
And as far as RTP goes, do you store the information, the RTP packets?
No, we're privacy friendly. We never care about the payload. We have something on the side for RTP recording. It's not part of Homer. So Homer, it's all about looking at the the headers of packets and not the payloads. So no recording, no playback, no looking into people's conversations. We can do everything just looking at the network traffic the right way. So there's no need to invade people's privacy to know if they had a gap in their conversation. The network is telling us.
Anyone? Ooh, plenty.
Thank you, Shlomi.
Thank you very much. We've been using Homer for a couple of years. I'm sure you've heard a lot of questions from me before. I'm Gunjan from Sydney. And it has completely changed our support model now. Our wholesalers also tell me what packets they see. So
I'd love to hear this.
Just a couple of questions. Just more about the graph which we saw. Is that something we can call through an API? We can.
Yes.
Okay. And if we were to upgrade from Homer 5 to Homer 7, is that a easy shift, or is it going to break something?
If you have an integration on top of 5, yes, it is going to break it. This is why we have the hybrid models. So you could choose to keep, let's say, the 5 core or UI or API if you have an integration with it, and add the time series support. So there's different steps into it. You can either do a full upgrade, or you can do the partial one, depending where you stand on that point. And I think you do have an integration, right?
We do. We'll see you later on.
Yes.
This question. This is my colleague who's been working on Homer as well. So.
Well, the next one you're not going to have to swear so much about. So porting the integration to the new API is going to be probably a breeze compared to the old one.
Just an FYI, I've sold Homer product to a couple of guys already, so I'll probably take one more T-shirt.
I think you deserve it.
Thank you.
Thank you. All right, thanks everyone, and thank you again for listening.